Hello, welcome to an introduction to acids and bases. I will be going over this in our lecture on Wednesday, but this intro, maybe as I'm going through it, hearing it a second time helps, and maybe when I ask questions, some of you will know. And it is also an introduction to your kitchen chemistry lab on pH and cabbage juice to give you a little bit of instructions. And another purpose is hopefully it will spark an idea. If you haven't picked a famous chemist yet, you might get an idea here. And also spark an idea maybe for some of you for your demo experiment to do. And this is me, maybe. Here I am. So I am Joy Sherpa. I'm your teacher in case you haven't met me. And I am properly attired for doing chemistry. My goggles, which are all on campus. So here we go. So let's talk about acids. So darling, you're as sweet as vinegar, and we all know, oh, vinegar is not sweet at all. Vinegar is very tart or sour. And the word sour, that's where the word acid in Greek is acidus, and acidus with the US ending means sour. And so anything you eat that has sour, it makes you pucker up like that. It is an acid. So all of our citrus, vinegar, and we add sugar because we like sweetness. And piling on the sugar, if you test the sugar in your home, it will come out neutral pH. But in your body, as I talked about in the the acidosis, this is what puts you in chronic acidosis, is the amount of sugar and processed food that we eat, because it has this huge acidifying effect on our body because it doesn't have the nutrients, and so it robs our body of nutrients. All right. Acids are very dangerous to work with, or you just want to use caution. They were on the Alchemist original table of the elements. They have many uses, and including in batteries, we use acids, and this is one of the dangers, is they actually do cause corrosion. They eat away at metal, and they will burn you and I. So they will actually, high concentrations, will eat away at our skin. It has to do with what an acid is. And oh, yes, so the acidity of soda, as well as the amount of sugar in soda, will have that effect on your tooth. So I don't recommend that as your demo, but there might be something else you can do to show the effect of Coca-Cola. And if you still are drinking Coca-Cola, let's just stop for yourself. Acid rain, I have a slide on this and 2 slides. So the pH of the rain has changed. And of course, the most acidic place in our body is our tummy, our stomach. Our stomach has hydrochloric acid, HCl, and so the pH of our stomach is 2, extremely acidic, but that's actually important. Without that stomach acid, the stomach acid is there because it unwinds or denatures proteins. And that allows then the enzymes to come in and cut it apart into individual amino acids so you can then absorb it, the amino acids. And that's part of the issue with gluten, that we change the sequence of gluten, and so the enzymes can't recognize this new sequence, and they can't cut it down to individual amino acids. Anyway, that's a side note. Also, we absorb other things at a very low pH of our stomach, and that is one of the problems with antacid. So antacid is something that neutralizes stomach acid, and then you don't absorb vitamin B12 and calcium. This slide I thought was really funny, this meme, because I Googled definition of acid just out of curiosity, and I got everything about LSD. But antacids are, of course, alkaline. Before we get to that slide, this is a quick slide about acid rain. Acid rain, or the sad saga of SOx and NOx. Wonderful paper, student turned in like 24 years ago. And so SOx is any sulfur oxides, and NOx is any nitrogen oxides. And so nonmetals with oxygen, we'll talk about this in class also, forms an acidic reaction combined with water. So when you combine it with water, you'll have H2 SO3, SO4, HNO3, HNO2. So sulfuric acid, nitric acid, some serious acids, and it changed the pH of the rain. The source of sulfur oxides is coal burning. There is no such thing as clean coal. And the big source of nitrous oxides is all our electricity, because when you get a huge amount of energy, lightning causes it too, the nitrogen and oxygen in the air then can react and form nitrous oxides. So this just shows some of the effects. The biggest issues of this are places that have high industrialization. So a lot of Europe, and also the Midwest. So like Ohio is one of the prime areas, and the pH of the rain has changed, which is changing the soil chemistry, and the trees become susceptible to disease. Think about it. My other slide showing acidosis, we change the pH of our bodies, we become susceptible to disease. The planet, we change the pH of the rain for the planet becomes susceptible to disease. And the pH of the water changes, and it pulls calcium minerals out of the rocks and changes the water, and the fish can't survive. And it eats away at anything that has the metals, so calcium carbonates and magnesium carbonates. So a lot of statues in Greece and Rome are gone in the past couple decades. And so I usually would say, if you're somebody who's really into Greek mythology, you better go now, except you can't go now, because nobody wants Americans there right now. And the Taj Mahal is, I can't remember if it's calcium carbonate or magnesium carbonate, but it is being eaten away, and it's something like in 20 years, it will be also, could be gone. And that's why we should all be horrified. All right, so an antacid is a base, and bases are soap. And so I always ask, so what's a base taste like? And half of the class knows apparently what soap tastes like. I personally don't, because I was such an angel as a child and still am. And so I never had to put soap in my mouth, but soap is what bases taste like. The other word for base is alkali. So those two words mean the same. Alkali is the alchemical name. So whenever you see the AL prefix, it means alchemy. So the kali is for kalium, which is potassium. And this is the definition from Google: neutralizes or effervesces, which means makes a gas when mixed with acid. So it's usually hydrogen gas, and it will turn litmus blue. And I'll talk about litmus paper towards the end of this. And it's caustic. Caustic means it burns you, it eats away at metal, just like acids do. So corrosive, caustic, same thing. We would be wearing gloves in lab. We would use precautions. You would be told very specifically you need shoes and socks on, and sometimes I have to get you guys lab coats. A lot of the batteries, like the smaller batteries we put in our calculator, are alkaline batteries, and that's why they're called alkali batteries, because the solution in there that makes the electrons move is a basic solution, such as NaOH or KOH. And so most people associate bases with hydroxide. So our cleaning supplies, baking soda, these are your bases. Windex, Drano, serious base. And the other taste that goes with bases is the bitter taste. So all of your alkaloids, so coffee and chocolate, the bitter taste tells you you're dealing with a base. In fact, alkaloid means it comes from nature. It's a base that we extract from Mother Nature, and it is a natural defense because it's repelling. Things don't want to eat it because it has this bitter, yucky taste. So caffeine, nicotine, morphine, and it is nitrogen. This is going to be key that we will learn as we go through acids and bases. When you see the nitrogen, you're thinking base. And as we go through the next slides, we'll see why. So some of the classic definitions. This is from 1887, and nobody has picked this gentleman yet. This is Arrhenius, and some of you just finished Chem 222 this summer, and a lot of you finished it in the spring. And we end with kinetics and this equation, which you do not need to know for the final. You just need to remember what that capital E sub A stands for, which is activation energy. And so there's Svant. He gave our classic definition of acids and bases, and he said acids donate hydrogen ion and bases donate hydroxide ion. This is the definition most of you know from high school sciences. We're going to go with the one on the next slide, but it is because of this assumption. It assumes you're always in a water environment, which is a great assumption because you and I are water-based and this planet is water-based. But there are other places acids and bases can show up. He won a Nobel Prize in 1903. I don't remember if it was for acid base, for this equation. He also has a crater on the moon named after him, which is really cool. And oh, he back around the turn of that century, around 1903, when he won his Nobel Prize, he also said, oh, this industrial revolution is warming up the planet. I don't remember if he's the one who coined greenhouse effect, but he wrote an article about it and talking about thermal equilibrium, our topic of the term equilibrium. Anyway, did a lot of stuff. And then we go to, this is definition we will be using in our chemistry class. And both of these gentlemen, nobody has picked them. And their definition, there is both of Bronsted and Lowry. I believe, I know at least Bronsted has the umlaut there, but an acid, they said, is a proton donor. So a proton is a hydrogen ion. Hydrogen, remember, has one proton and one electron, and the ion, when you remove that electron and make it a hydrogen positive, it is now just a proton since there's no neutron. And so this is their definition. So it shows you down here that our acid is giving the hydrogen to the base. The acid then becomes, without its hydrogen, we call it the conjugate base. And again, I'll be going over all this in our notes. So the acid loses a hydrogen, becomes a conjugate base. The base has now picked up a hydrogen, and we call it now the conjugate acid. So conjugate means it's pair. So acid donates the proton, base is the acceptor of the proton. And then one more definition, and nobody has picked Gilbert Lewis. You all know Lewis. He is famous. His definition course is a little bit different. These are some of his pictures of Lewis dot structures. So he is our bonding guy. And he also came up with a definition. Now, electron dot structures, Gilbert Lewis was all about electrons. And so he said acids, rather than being a proton donor, he said they were an electron pair acceptor. And a base then was the donor. And the classic example is this. So nitrogen, again, nitrogen's a base, both of the previous definitions. The nitrogen has those lone electron pairs shown there in green, and it will donate them to the boron, but it doesn't give them up. It's that bond between the nitrogen and boron is a special bond called a coordinate covalent bond. And so they're sharing, but both shared electrons came from the nitrogen. And so that's what Gilbert Lewis said was his acid and base. Oh, and how about all these famous chemists? Nobody's picked any of them. So in case you don't know me, I'm the one in the teal green jacket. And there's Bernadette. Many of you had her. And there's Dr. Whitman, who's the shortest one. Somebody's actually shorter than me. And then I don't know if any of you had Dr. Russell. So there we go. All right. I'm going to talk about strong acids and weak acids. We'll talk about this again. And so I circled at the bottom here. A strong acid is stronger. It's going to be more acidic. And it's more acidic, and this is why we had to do equilibrium first, because it completely dissociates. And so you can see in that beaker, it completely breaks into ions. Now, we don't call it ionization because it needs the water. The water actually pulls the hydrogen off. So it's not an ionic bond. Acids make a covalent bond, a very polar covalent bond, and then the water pulls the hydrogen off, and you're left with the chloride ions. So the mistake in this slide is you don't actually have ever hydrogen ions. It's always hydronium. And that's how I will be drawing it on the board, and you will be too. As opposed to the weak acid, which is H2CO3, and it is in equilibrium. It's only partially dissociating. So only a small percent, like 1%. So the equilibrium's lying mostly in the reverse direction where it does not dissociate. I will give you a list. We're going to go with 6 classic strong acids, and every other acid we run into, we consider a weak acid that we will always write 2 arrows. And so that will be something I will talk about on Wednesday. All right. So pH scale, right? It's the little p, capital H. Where did it come from? Oh, this gentleman, who also nobody has picked. This is Soren Sorensen, and it was only 111 years ago. This blows my mind, because we all just take pH for granted, but it wasn't around 120 years ago. He came up with the concept, and it is always written as a little p and a capital H, the scale. Please don't say that. I'll tell you my story in lecture. And it was a convenient way, it is an extremely convenient way to express acidity, and it is a logarithmic scale, as I mentioned in another slideshow. So every point is a 10-fold change, just like the Richter scale is the other famous logarithm scale. So the difference from 2 to 7 is not 5, it's 10 to the 5th, or 100,000-fold change. All right. Oh, sorry. Go back one. And this just shows, again, common acids, if you need ideas for lab, and some common bases in your house. Eggs would be fun to check, the yolk, as well as the egg white. I don't have eggs in my house. All right. And if you want, you can buy chemistry coloring pages and color by pH, which is really cool. There is actually a poo scale, because chemistry has everything. And I talked a little bit about the poo scale. So if you eat crappy food, you don't poo. That would be because you're extremely acidic. If you keep your body alkaline, so the pH and the pH scale and the pOH scale, it's not read as the poo scale, but they complement each other. And we'll talk about that in lecture. Everybody talks about the pH scale. I actually never learned about the pOH scale, and so I had to teach about it. And now everybody seems to know about it, but I think it was just something that teachers wanted to teach about. All right, if we were in lab, and some of you, like Alexander today, say he has lots of gizmos at home, might have a pH meter. And if you want, when you do the lab, you are going to make the cabbage juice, but you can check it also with pH meter and see what you get. So we can, we've made electronic meters to measure pH, but before we had that, they had pH paper, and there's a whole bunch of different dyes that change color at different pHs. So if you were testing something like at the top, methyl violet, if you're testing something very acidic, you'd want to use methyl violet to tell the difference between pH of like 0.5 versus pH 2. Down towards the bottom, phenolphthalein, which is what we would have been using in lab, is something that tells us when we've gone from acid to base. And they're beautiful. And this was really cool. I just found this. There are a whole bunch of natural dyes, like turnip skin and grape juice and onions. We're going to do the red cabbage. So there you go, Erin. It's called red cabbage here. I call it purple cabbage. I don't know why. So we're going to do the red cabbage, and you can see the colors. And I think I put a little slide in your thing. Litmus paper is actually lichen. And it was interesting, when I made the slideshow, I do a meditation different times of the day. And at my mom's house, I always sit by this one tree. And right after I made the slideshow, I turned and I looked at the tree, and it was covered with this lichen. And it's a specific lichen. I don't think I wrote down the name of it, but you can Google it. And so litmus paper, when it turns, if you take blue litmus paper and it turns a pinkish red color, that tells you have an acid, because acid rhymes with red. These are the gimmicks that I'm supposed to teach you to remember it. So that's the one over on the left. If you take pink pH paper and it turns blue, so blue and basic both start with a B. So blue is basic, red is acid. And there's a little gnome to help you remember. There are actually many natural ones. This is Hydrangea, which is blooming right now in my backyard. And it does change color with the pH of the soil. And it has to do with, there will be a chemical compound in the lichen, in cabbage I talk about in the next one, and in, they're all different ones, and they change color with pH. And so based on our soil here in Oregon is very acidic because of all the pine trees, and so we get really beautiful hydrangea. And a lot of the country people will treat the soil to get different colors that we get brilliantly naturally. So what are you using? You're not going to go out and lick the lichen, but you're going to go and get some red or purple cabbage. And again, if you don't have any and you live near me, I'll bring you some. You just need one leaf, and then you're going to eat the rest because it's really delicious. Don't pay attention to your dog and cat who might be horrified. So this is, as I mentioned, I teach a kids class, and I actually have done this with my class. So you guys are going to extract pH indicator from cabbage, and this is a quick slide. It's really the simple. You chop up one leaf of red or purple cabbage, whatever color you see, and you heat it to boil, you let it sit, you strain it, and you have an indicator. And then you're going to test like 13 different things in your house, and you're going to write up a lab report about it. So there's lots of possibilities, and you can be creative. I'm so excited to see how creative you can be. This is a really cool slide that I got from, I guess, Andy Brewing. So the cabbage will come out this purplish color in the middle. The acids are going to turn in the reddish, and the bases are the ones that are really cool because you get a whole range of colors. All right. So looks purple to me, Erin. Your experiment. Soaps. Window cleaner. You could use whatever that is, mouth gargling stuff. Lemons, limes. Oh, soda. You got to pick something clear, or clear-ish, so you can see the color change. So Coca-Cola, unfortunately, the dark color, you're not going to be able to see the color. So it is a setback for the lab. So unlike a pH probe where you can put it in and it will give you the numbers no matter what, you do need a clearish solution. A lot of the mouthwash and the shampoos and stuff, they do have a color, but the color will change when you add the cabbage. So if you want to try that, you can do Tums. You would just smash them up into a little bit of water. Pepto-Bismol is really fun. The kids love to do that one. Drano works really well if you have it. Again, I give you a list of possibilities, and you can go way off my list. What you have, try it. Be creative. Gatorade. Yeah, orange juice actually comes out interesting. Milk, if you have milk, any type of milk. You don't have to go out and buy anything. You'll have plenty of stuff. I think I have you try 12 or 13. And yeah, if you have beer in your house, that's Dr. Whitman. She's just barely 21, just was barely able to. Yes, take her there, back when you could go out. And if you want, when you get done with the cabbage, I prefer to eat it, or you can make a fun decoration and take a picture and include it in your lab. You do take some pictures and embed them into your lab report. Really good. You also are going to do a thing where you're going to take color blending. So we all learn, like back in kindergarten, if you mix red and blue, you get purple. Well, here when you mix red and blue, well, you should get purple, but you might not. We'll find out. And then there is a bonus challenge. That's a small bonus if you can do it. Yeah, I got to take a picture of it. Is if you can make a rainbow. Yeah, tell me what you did to get red, orange, yellow, green, blue, and violet, as well as eating the rainbow. We talked about that. That's your 30-day challenge. One possibility, which again, your purples, anything you see out there that is purple, including the cabbage, eggplant, artichokes, onions, grapes, etc. It is got anthocyanin, which is a beautiful molecule, which is a serious phytochemical, antioxidant, super molecule. It's from the Greek word meaning flower dark blue. I'm not going to try and read it. And it's the purple pigment. And it does change color with pH. So because I want to keep all of you healthy, I'm going to tell you 7 life-changing reasons to eat more purple. or dark red, whatever color you see there. Just eat color, eat the rainbow. Go for it for 30 days and do it with a loved one. It will boost your brain. It will make you smarter. It will slow down your mental aging. It will boost your learning and memory. That will slow it all down. I had a student once, and he was a lovely student. He's a chiropractor now. This is quite a while ago. And he was never my top student, but he had the highest score on the final. And we used to all meet after the final, and I would show up an hour later and bring them their grades. And I just walked in, and everybody's there waiting for me. And I just walked up to him and I said, "Joe, what did you do today?" He didn't know yet, that he'd had that top score. And he just blew it out of the park. And he said, I said, "A really nice day. I just had a nice salad, and I think he said a little bit of tuna fish, and I went for a nice walk." So he came in really relaxed. He actually grew up, his parents were also chiropractors. He wasn't allowed to have candy. And his mental function was just top of the game. Yeah, the cat is horrified by that. My cat is sitting right behind me right now, sleeping. All the animals are sleeping, mesmerized by my voice. Have I put you to sleep too? Maybe that would be your meditation. Joey's giggling background. All right, so berries have lots of anthocyanins. So it said 7 things. So it would be, that was one possible molecule. The R's mean different kind of carbon groups coming off. That's why we have different colors, but is good for your eye health. Also for immunity, important these days, for cancer, for your heart health, and your liver. Oh, and the common cold. Yeah. And I promise that will not happen, but it does also help with obesity. Again, I just been reading this really cool book. All right. Eat more purple for a longer life. Go for it. Go vegan for the whole term is your challenge. What the heck? All right. Let's talk about safety, because you are going to be in your kitchen. And I can't remember. I think it was Sam had asked me the question today about having to wear goggles. So safety first in your own kitchen. So Johnny was a chemist. Johnny is no more. What he thought was H2O was H2SO4. I don't think any of you have sulfuric acid in your kitchen, but attitude is the most important. Attitude and attire. So, if you wear flip-flops, if you wear your goggles over your mouth, yeah, let's have a perfect, this is my brother, my twin brother, doing a demo for the class. I think I did this demo the very first day of 221 there's 9 of you. I'm so excited to shout out to you who've been with me. First day of Chem 151. So my brother happened to be visiting, and it was our birthday, which is in October. So you're all going to miss it this year. And we also make ice cream for the class. It'd be a cool, fun demo. You make ice cream for all of us and explain what's going on. But Wednesday, the day when I'm doing the acid bases, it is my sister Anne's birthday. She's the one all the way over, I'm assuming on the right, the dark hair. I'm the one in the middle falling over. And so it's at my grandma's farm. It's my cousin Susie. And so I got the hearts to line up over their heads. Anyway, it's her birthday on Wednesday. And so we always call her up as the class. And so somebody's got to remind me, because sometimes I just forget things. I just saw I'm recording to the cloud. This is going to be interesting. I've never done that before. All right. So don't work unsupervised in your kitchen. No unauthorized experiments. Because, you know what? We're not there to tell you what to do. And horrible things could happen. Yeah, some of you are going to be amazed. Some of your famous chemists that they survived. But anyway, there's all the way on the right with the red shirt tied around her waist. That is Dr. Cohen, who is the organic chemistry teacher. And this is every year, the day before school starts, we all go for a hike together. And we'll do it again this year. We might just have to be socially distanced in our picture. No eating or drinking in your kitchen. Even when your chemistry teachers say, "Oh, please eat." And this is why I'm going through this, because I had all these fun pictures I wanted to share. Yeah, if you have any injuries or accidents, you got to report it to us, except we are not there. So we can't hear about it. Although I guess you can write to me about it. And don't leave a mess. You got to clean up. Don't leave the floor wet, please, because I am not there in your kitchen to clean up. And your chemistry teachers from the previous term, they're not there. They're saying, hey, Jessica, thumbs up, clean up. And if I was in your kitchen, I'd be making a bigger mess than you. And so you don't want me in your kitchen. So have fun. Just play chemistry. Play chemistry with me. Be inspired. Do something really cool. Take some cool pictures. And I will see you soon.